Yes, Jai Hind to all of you. I am Priyanka Sharma, Assistant Professor AC Department. I am going to present my video lecture over the topic clippers. It is basically related to the subject Fundamentals of Electronics Engineering, that is BC 101. Basically, this topic is very useful for first year students so that we can give the basic concept about the clippers and we can able to solve the numericals over it. So first of all, if we start with the clippers basically of two types, series clipper and parallel clipper. So first of all, if we're going to start with the basic concept of diode clippers. So clipper is a circuit which is going to clip or remove some portion of the signal. So if we see here the square wave signal, in this if negative cycle is clipped, negative cycle is clipped, that is called as negative clipper. And in the other circuit, we are also seeing in the triangular waveform, we see negative cycle is again clipped, that's why it is called as negative clipper. So in this we can see here, removes the signal cycle and this gives you the clipper concept. So if we see here, basically the diode clipper circuits of basically two types, series clipper and parallel clipper. So if we first of all, we start with positive clipper. If we are going to see the positive clipper here, positive clipper circuit, it has a very basic circuit. You can have series clipper. So in this we are going to see the diode is connected in such a way, and if we have given the signal here and a resistor is connected here and output is taken across the resistor. So if we take the output here and we will give the input here, in this case this is the input V in and we get the output here. So how we will get the output? In the same way as we had studied in the rectifier circuit. First, if positive cycle occurs, first for the positive cycle, if we see the diode for the positive cycle, it will going to reverse bias the diode. That will be reverse bias diode and it is treated as open circuit. So in the open circuit, no current flows and the output will be 0. We will get the output 0 for the positive cycle. And now if we take the negative cycle, for the negative cycle, this diode will become forward bias. Diode will be forward bias and becomes short circuit and the current starts flowing. Current flows. So in this we can see here, if the current flows here when the diode is forward bias, the output will obtain as it is. So output will be equals to the input, and since it is forward bias in negative cycle, we get only the negative cycle here. So we can say here the positive cycle is clipped. So that's why it is called as positive clipper. In the same way, we can also make the negative clipper just by reversing the diode. So negative clipper will going to clip the negative cycle and we get the same output as we had here. For the negative clipper, we will get, in this case, positive will be obtained as it is and negative cycle will be clipped just by reversing the diode. So this is the very basic thing we should know about the clipper circuit, that how it can remove either the positive cycle or negative cycle. Now next we will going to see if we have to remove only some portion of the signal. That means if we have to remove either a small part of the signal, then what we have to do? We have to go for the bias clipper. So in bias clipper, we have to add a DC battery supply so that it can be clipped at any position of the cycle. So if we talk about the circuit of the bias clipper, we can see here a DC battery is connected just before the diode. So it can have any voltage. Let's say we have taken V and we have the input voltage Vi, that can be of any type, sinusoidal, triangular, square wave, and we have a diode connected here. So this is called as biased series clipper. Now if we will going to see its concept, how it will going to work, we can take one example. If we had taken the example, let's say V voltage is 5 volt and diode we had taken as the ideal diode and input we had taken as the square wave with positive input 20 volt and negative input minus 10 volt. So if we again going to start its analysis with very first cycle, that is positive cycle, for positive cycle, or we can say if we take the voltage Vi as 20 volt, if we have taken the voltage Vi as 20 volt, then we can have for 20 volt, we have to take the voltage at diode, let's say V1. So V1 will be what? V1 will be is taken as plus 20 minus 2 plus 20, and this is 5 volt, that is plus 25 volt. So this plus 25 volt will going to make diode forward biased. So if diode will be forward biased, again the current starts flowing. If the current starts flowing, we can obtain the output across V out. So what is the output we will get here? The output we will get here, V out will be equals to coming out to be 25 volt for the positive cycle. So this we had obtained in the output here. Now if we take the negative cycle or lesser than 5 volt, if we take the negative cycle, that is minus 10 volt here. If we take the minus 10 volt here, instead of minus 10, that means this end will be negative, this end will be negative, this end will be positive, and this is coming to be 10 volt, and this battery is 5 volt, and the diode is connected here in this way. So if we want to find the output here, then this V1 we again have to calculate before the diode. V1 will be equals to minus 10, then this will be this battery is negative, minus plus, so this will be plus 5. So the output obtained, the voltage before diode obtained is minus 5 volt. So this minus 5 volt will going to make diode reverse bias, and it is acting as open circuit. So if the circuit is open, no current will flow, no current flows, and the output obtained here is 0 volt. So we can say here the voltage below the 5 volt will be clipped here. So we will obtain the graph like this. For the negative or less than 5 volt, we obtained 0 volt. So we can say that the negative portion will be clipped here. This portion will be clipped here, which is lesser than 5 volt. So this will give the brief idea about the bias series clipper. Now next we are going to study about parallel clipper. In series clipper, we had seen here diode is connected in series connection with the battery connection. Now if we see the parallel clipper, we can see the output we will take across the diode itself. So we can take the output across the diode, and it is called as parallel clipper. So we can see here again, if we give different signals, either square wave, triangular wave, we can clip again positive cycle also as well as negative cycle. So if we clip the positive cycle, then it is called as positive clipper, and if we clip the negative cycle, it is called as negative clipper. So this is the basic circuit of the parallel clipper. This will going to work in the same way as we had seen for the series clipper. So in this, what we had seen, we had connected only one diode. If let's say the diode is connected in this way, and we had given the input here, like we had given the AC input Vin, and we have to take the output across the diode. So if we going to solve it for positive cycle, now let's say if it is for the positive cycle, for positive cycle this diode will be forward biased. If diode will be forward biased, it is replaced by which path? Short path, and short path. So the V out across the diode will be obtained as 0 volt, because the output at the shorter path will be 0 volt. So we can say that output for positive cycle will be 0 volt. So we can say positive cycle is clipped here. Now if we talk about the negative cycle, for negative cycle, this is, if this will become now negative, this will become positive, this diode will be reverse bias here. So diode will be, if diode will be reverse bias, again no current flows, circuit will be open. So for open circuit, we had obtained, if we draw the circuit here, for open circuit, we had this much of voltage in the input, Vi, that means the negative cycle is coming here. So Vout will also be equals to negative cycle input. That means Vout will be equals to minus V. So we had obtained here only the negative cycle. So we can say here positive cycle is clipped. So this is called as positive clipper circuit. In the similar way, we can design the negative clipper circuit just by reversing the direction of diode. So now if we again take, we can say the different combinations of series clipper here. We have the simple positive clipper, positive series clipper, and this is the negative series clipper, and the output obtained here is this. Positive cycle is clipped here, and in this case negative cycle is clipped here. And we have different bias series clippers for different combinations of diode and battery. First we had connected battery here with positive terminal connected to the positive supply and negative is connected to diode. And now if the battery polarity is reversed, diode is in the same direction. Third configuration will be battery polarity will remain as it is, diode configuration is reversed. Fourth configuration, battery will remain as it is, diode configuration is reversed. So for these four configurations, we had obtained different sets of waveform and different clipping of the signals. So we can solve it in the same way as I told you the procedure before for the bias series clipper. This will be the combination of parallel clipper. If we take the example of parallel clipper in case of biased circuit, we can take one example of biased parallel clipper. Biased parallel clipper. We have one input signal here, positive cycle and negative cycle. Let's say it is of plus 10 volt, this is plus 10 volt and this is minus 10 volt, and we have one diode connected here, let's say in series with one battery voltage of 5 volt. So this is one of the parallel clipper we had taken. Now if we will going to solve this circuit. Let's say we had taken the 5 volt DC battery over the waveform. So first we are going to plot the waveform in such a way that AC signal is connected with the DC voltage in such a way that if positive terminal is above and negative terminal is downward, we can show it on the positive part of the axis. This is 5 volt. So we can divide the signal in two parts, greater than 5 volt or lesser than 5 volt. That means here Vi is greater than 5 volt and below this 5 volt Vi is lesser than 5 volt. So we can divide the signal in two parts, Vi greater than 5 volt DC supply and Vi lesser than 5 volt DC supply. And now we are going to take two cases. Case 1, if we had taken Vi greater than 5 volt, Vi greater than 5 volt. Now look into this, ki how the diode will behave. Either it will be forward bias or it will be reverse bias. So if Vi is positive and this is greater than 5 volt, Vi is greater than 5 volt. So if it is greater than 5 volt, that means this potential is higher and this will be lower potential. So if greater potential is connected to positive terminal and lower is connected to negative terminal of diode, so diode will be said to be forward biased and it is behaving as the short path. So if we draw this equivalent circuit, we will obtain the circuit like this. This will be short and the battery obtained here is 5 volt. So the output obtained is coming out to be plus 5 volt for Vi greater than 5 volt. So in the graph we can plot like this by drawing the projections at 5 volt. We can see here for greater than 5 volt we get the, for greater than 5 volt, that means for this region we get the output at constant value, that is 5 volt. Now if we take another case, that is case 2. Case 2, Vi lesser than 5 volt. In Vi lesser than 5 volt, all the positive portion and negative portion will comes. So for Vi lesser than 5 volt, this end will be at lesser potential and this end will be at higher potential. So if lesser is connected to positive terminal of diode and higher is connected to negative, now the diode becomes reverse bias and becomes open circuit. So if we redraw the circuit, we will get diode open here. So for at the open circuit, we can see here output is same as input. So if we draw it here in this circuit, we can see the output will be obtained same as input. So in this way, we can see here some portion of the positive cycle will be clipped here. So in the biased parallel configuration, we can see here how the clipping function will take place. So accordingly, again, same as biased series clipper, we have different configurations of parallel clipper also. So we had taken this configuration. Similarly, we can have another 3 configuration with diode position same and battery terminal reversed. And here battery terminal is reversed and diode portion will be also reversed. Here the diode is reversed and battery terminal is reversed. So we have different 4 configurations here. And at last, we have the combination of 2 parallel clippers, that is called as combinational clippers. This will give you the output waveform of one of the clipper and another waveform for another type of clipper. So this will give you the brief idea about how the clipper circuits work and how their numerical analysis can be done. So after this, we can have a good idea about the series parallel clipper and series clipper and parallel clipper configurations, and we can able to analyze different configurations by changing the positions of diode and battery. So this lecture is end up here. Thank you for Jai Hind.